All right, well, once again, I've put together a presentation on railroad communications. I'll say it another time. I did a presentation a long time ago about railroad communications, and quite frankly, I think I've learned a lot more since then. So I'm hoping to share what I've learned and build off of what I did present before, although I'm pretty sure nobody here has seen that presentation, so may not be able to judge. But here it is. So let me move forward. So as you can see here, this is the introduction here. I have the contents for this talk. What I'm going to cover, I'm focusing in on communications. There's a lot to cover in railroading, so I've tried my best to focus in on specifically communications in regards to how it might actually be of interest to amateur radio operators and anybody who's maybe just a casual listener to radio. So I focus on VHF and UHF and try to cover as much as I can there, although there's definitely going to be some gaps, and I'll kind of cover, at least give some indication of where to go from there on the gaps, which is kind of that second to last item, which is other railroad facts. And then, of course, I'll leave it open for questions just in case you don't interrupt me in the middle. One thing to start out, the motivation behind this presentation comes from the fact that QST, it's probably hard to see, but back in February of 2019, a writer, or one of the editors for QST, wrote an article called Radio on the Rails. If you're an EWRM member or you still have your issue from back then, you can take a look at it. It's, I think does a pretty good job of kind of introducing railroad communications and gets maybe the ball rolling for anybody who wants to learn a little bit more. And then as you can see here, I have a few goals of just kind of providing some railroading knowledge, railroad communications knowledge, and as always with railroading, spreading the message of safety, which is of critical importance as always with railroading. And then discussion, a little bit of regulations. So which leads into the who am I? Why does it matter? Why am I talking about railroading? And as some of you probably know, I've been working in the railroad industry for somewhere around 8-9 years now. I have an electrical engineering and systems engineering background, and I've worked on various aspects of railroading, including locomotives, locomotive control systems, track inspection, and data analytics and data science. So I've learned a lot, just picked it up on the way, and hopefully I can share all that with you and hopefully you enjoy it. All right, as I said, safety is always the first thing. So while it's really not something that can be done in a virtual environment, if we were in person, I would have first and foremost done a safety briefing, likely even before I started this presentation. There's a few items here discussing, kind of some items to think about when you actually go to visit the railroad. The two I should point out, or three I'm going to point out, is one, the foul of the track. If you go to a railroad and you're standing around and you're looking and you step foot on the ballast, the foul of the track is considered 4 feet from the rails, typically. Sometimes some railroads will designate as further, but essentially that is the danger zone. That's the area where if you're standing within 4 feet, you could the very high likelihood of getting injured. So, and once you break that 4-foot barrier, you're actually now trespassing. So keep that in mind if you do go to visit a railroad, and also keep your car parked at least 25 feet away. And one thing that a lot of people don't really think about, trains are actually a lot quieter than you might think. Not many people realize that you could be standing on the tracks and a train could come out of nowhere and you won't even hear it if you're not facing it. It's kind of more common than people realize. And I can say there's been a few instances where I've been walking through a rail yard and it has frightened me seeing things that move that I never heard. And I'm sure as you all look at this picture, you can see exactly what's wrong here. what's even more disappointing about what's wrong in this image is that all these guys who are standing in the rails and on the rails and all around, those are all railroad workers and employees. A lot of them actually were people I was working with on this locomotive, and they're standing in the middle of the tracks. So don't be like them, please. All right, on to the good stuff. Let's start out with some VHF comms here. Being where I work nowadays, regulations are kind of a significant part of my career now. So it's kind of helpful to understand a little bit of the background of the regulations that do exist surrounding the railroad. Specifically, this I bring up part 220 of the CFR 49, specifically because it talks about what's required for communications, especially voice communications of the railroads. So what is of interest probably most likely is going to be subpart B that talks a lot about actually on-air operations, much similar to the AAR operations manual for amateurs. There's a lot of stuff there, although, you know, certainly in the railroading environment, it's not nearly as substantial in certain ways as the amateurs operating manual. Of note, the channels voice channels that are utilized by the railroads, first of all, they must be published in a timetable, which I'll cover in the next slide. But all the channels are specified on the right, which goes from about 159 megahertz to 162 megahertz, just as a general. But you can see the specific area listed on the slide here. And you can program each of these channels in. I'd suggest going from probably channel 7 and 97 if you want to get the most commonly used channels within the US. And another option is to actually do edge scanning, which I do on my car, the scanner in my car. I actually have it set to edge scanning. Just if I'm driving in an area that I haven't been in quite some time, you might pick something up you just haven't heard before. And then finally, I mentioned PTC here. I'm trying not to open up the Pandora's box of PTC. However, PTC, positive train control, you may or may not have heard of it. It's a interconnected system that has overlaid onto existing rail infrastructure that is intended to reduce the number of human factor accidents through various means. There is controls that go within a locomotive that the operator can see and understand when they're going over speed and when they're disobeying certain rules. And PTC has been designed to kind of avoid that. The one thing I can say about as far as an amateur radio who wants to casually listen in, you can listen to these voice channels up above, but when you're talking about PTC, every manufacturer who produces PTC equipment that gets deployed to the railroads, they can be different. Things can be different for each manufacturer. The only caveat being that all this stuff has to interoperate between railroads. So just something to keep in mind. And as PTC develops, there may be more that the casual listener might be able to experience. So next, I mentioned the timetable. So this here is a little mock-up of a timetable. I'm sure the word timetable, whenever it's said, most people think about a schedule of trains, which you're familiar probably with a timetable for passenger trains or bus routes, or even airlines have things, schedules for the planes. That's what is kind of the publicly published timetables, passenger timetables. And that has times when a train will be at a station, and laid out so you know every train and every number, when it's going to be there. For freight, those schedules don't really exist. And instead what gets used is an employee timetable. And there's a whole lot of information in there. I'm not going to go through everything that's contained within it because there's a lot to cover. I mean, you can talk about speeds, you can talk about the mile posts, all that stuff. But what's most important for an amateur who wants to actually listen and watch trains and get has an interest in railroading is actually going to be the fact that radio frequencies and the channels that are being used by any given railroad is in that timetable. And what's kind of helpful about that is you not only know you programmed your radio, you put all those channels, and you can actually pick out which one specifically is going to be happening for the railroad that's closest to you or that you have the timetable for. As trains go past you and move throughout the system, there's a number of different things that the timetable lists, mileposts being pretty critical. A train will tell you which milepost it's at, and where you can actually look at the timetable and say, well, it's milepost 15.82 and I'm at 13.53. I know that a train's headed in the direction towards me, so it can help you kind of understand that. There's a whole course I could give on timetables, unfortunately, so I may touch back upon it in a minute, but I'm going to keep moving here and we'll come back if necessary. So one thing that was brought up in the article in QST, and I felt was necessary to mention, is the kind of things you'll hear when listening to the voice communications within on the railroad. As part of the regulations, all communications are required, as we're very familiar with, identification. A train operator usually is going to announce their train number or their locomotive number, and they're also going to usually try to identify the location they're at depending on what's going on for them. There's going to be also wayside equipment that actually enunciates certain things, which one thing I mentioned here is called a defect detector. And they actually are required also to identify, but I'll talk a little bit more about them in just a second. On the right side, there is one thing, and this is really where the article kind of starts to mention a few things, but doesn't have, I think, enough room to really expand on the details about it, and that's the railroading language. There is a whole, as the article puts it, there's a whole dialect going on out there. And you get familiar with it the more that you're exposed to it. But for the uninitiated, there's a lot of things that you might hear that, just kind of don't make sense right away. And the hole, he mentions the hole. When a train goes in the hole, it's being put into a siding. It's essentially letting another train pass it. That train could be coming at it or going another direction. That other train could be what we call a hot shot. A hotshot train is something like a high priority train that it's going to be going high speed, so it needs to get by whatever other trains, which I'm sure if you've ever rode Amtrak, you've probably seen at least one or two hotshots go by. They're those intermodal trains that have the well cars and those big boxes on them. Those tend to be the highest priority right now within the railroad industry. Also, the end of the cars, the locomotives, you have A end, B end, and then number 2 end, number 1 end. It all depends on, typically, you're going to have certain A and B end for rail cars or locomotives, depending on the actual people who are dealing with it. However, when you're looking at a locomotive, to you, and to me, if I want to look at a locomotive and I want to figure out what the front end of it, there's usually a little tiny F somewhere at the front of it. In fact, if I can pick something up to help illustrate this, I don't know if everybody can see, but right around here, there's a little F that sits right at this little point. I think it's right about here. It's probably hard to see. That F designates where the front of the locomotive exists and also actually indicates the seat that the operator sits in, which orientation that seat is in. In some instances, a locomotive such as this, you'll find that the F is at this end, which means that the seat that the operator sits in the front is actually facing in the rear direction for what we would commonly consider the front and the rear of the locomotive. Finally, I'll mention one other thing. You see the picture here, it says do not hump. You may have a few assumptions about what that means, but it's may not be, if you're not familiar with railroading, it may not be exactly what you think it is. Without going into too much detail, there's such a thing as a hump yard, which is essentially a hill that rail cars are brought up to the top of and then released and let down. That's called a hump yard. It's a way to classify rail cars and trains. There are certain cars out there that have delicate equipment in them, and therefore they should not be pushed over that hump. And so they will have typically a big sign on them that says, do not hump. What is a defect detector? So I mentioned in the last slide that wayside equipment enunciates on the VHF frequencies that the railroad uses. There is two different frequencies that are used on the timetable. One is called, it all depends on the railroad, keep in mind, but a dispatcher frequency and a road frequency. The road frequency is the frequency that the operators of the trains will use to communicate with, at times, with dispatchers and with other trains. A lot of the stuff that I mentioned earlier that you hear in that previous slide, those are things, I'll stop over here for a sec, you'll hear things such as, you know, a crew announcing a control point or milepost that they stop by. Those are the things you'll hear from the crews. However, there's other things going on too. Defect detectors are a pretty significant piece of railroading in that they help determine if there's problems. So there's a few different defect detectors that I've listed here. They're some of the most common ones. Hotbox, which that's when the bearing that goes around the axle locks up and starts to heat up and has a lot of friction causing it to heat up. A hotbox detector will typically try to judge the temperature of those bearings and determine if they're too hot. And they'll actually announce that, hey, look, something's going wrong here. One reason I picked the images I picked here is because right here you can see that's a journal box. It's kind of not zoomed in, but right about here is about where the journal box, which is where that bearing is held, and that holds the axle. When those lock up, that can cause problems. And here, I don't want to confirm that this is, but this is about what a hot box detector would look like. Obviously, dragging equipment, you can imagine what that is. High or wide clearance, you can imagine what that is. Wheel impact. If you have a axle that's stuck, you know, you're talking about these metal wheels here, they can start to develop a flat spot. You can hear that if you're listening. If you ever watch a train go by, when you hear a really loud clunking sound from one rail car, it's probably a flat spot. There are detector sensors that actually will sit on the rail and can say, well, the impact from a given axle is too significant that there's got to be something going on, likely a hot spot. And maybe a little bit later, if anybody's curious, I actually have a flat spot story I can tell a little bit later. So that's a defect detector. What they actually transmit and why it's actually kind of useful and fun for the casual listener or the amateur who's listening in, they are required to identify the railroad and location. And that location can be identified by a milepost or sometimes any other means that the railroad so decides. It also tells you which track. So like in the picture down below here, you see there's 3 tracks. There's a train on 2 of them. It could be tracks 1 and 2, and then track 3 is empty. The defect detector might tell you. It's not always going to tell you, but it might. Other things that it might actually let you know is going to be the length of the train, the number of axles, the speed. Those are all possible things that it might transmit, and it's all up to the discretion of the railroad beyond identification and defect detection, what it's actually going to be telling you. And occasionally, there's one I can think of right offhand in Alexandria. I think it's at milepost 106.4 maybe. And actually enunciates at the beginning of the train, at the end of the train. And so if you happen to be able to know the speed, you could actually also tell about where the train is going to be relative to you when you hear that front of the train an enunciation from the defect detector. And as a note I should make, there's always more technology being developed in wayside detection technologies. If you can dream up a problem with a train or with tracks, and you can come up with an idea for how you can detect a problem, then there may be somebody working on it, but you may have a novel idea that could be useful to the railroad. All right. So next up is UHF Communications. We're familiar with certain digital communications. You know, DMR, right, happens within the 400 megahertz territory. There's quite a lot that actually happens within railroading in the 400 megahertz territory. There is, the first thing is what's called distributed power, and I'll explain a little bit about that on one of the next slides. And then there's also end of train devices. And I'm going to explain a little bit about it, but I will say there is a video that is online, a presentation given actually at DEF CON in 2018. And there's actually source code available for reading the end of train device data. But I'll cover a little bit more about that in just a second. Further into UHF is going to be the ATCS, the Automated Train Control System. There's a lot of ground to cover in signals and train controls technologies and how trains are actually, you know, different signals that are given and the different ways that tracks operate and control systems within the railroad operate. There's a lot of ground to cover there, and I've chosen intentionally to kind of avoid talking too much about ATCS for various reasons, but we can maybe talk about it at the end if there's a little bit of time, but I'm going to skip over it at the moment. And then I also just going to mention that AEI, automatic equipment identification, is utilized as well. That's RFID. It would be helpful if I had a picture, and I unfortunately couldn't find a good one that I had in my library. But essentially, there's an RFID tag on every rail vehicle, and it is used for identification by the railroad, and it contains a whole bunch of information that's kind of fun just to know. And those are the presentation that I'll reference that was done at DEF CON actually talks about that stuff as well. And then finally, RFID is being used not just for AEI stuff, but also for location identification in some circumstances. However, that is a new and burgeoning technology, so I won't say much more about that. Okay, what is distributed power? I mentioned distributed power in the previous slide. What happens is when you have a train, you know, you're going to have a lot of rail cars, right? There's going to be a lot of loads that are carried. And, you know, if you think of a very high grade, as Kevin kind of had actually brought up, that if you're going up a mountain, such as like the Horseshoe Curve in Pennsylvania, a lot of times you don't want to put all your I'm going to say power, all your power, locomotives, up front. What will happen is if you put all locomotives up front and you don't do a proper distribution of the loads, or if you don't have a completely empty train, any loads at the rear end of the train or when going up a high grade that are still pulling in the opposite direction can cause what string lining to happen. A good incidence of string lining, Harper's Ferry recently, there was that accident that CSX had while it was going over that bridge. And if you recall, a few rail cars just kind of fell off when that train was pretty much out of stop and it was just starting to move. There's a few different reasons why that could happen, but essentially that's the type of thing that would happen. And in fact, I think, was it back in 2019, the summer of 2019, on the Horseshoe Curve, there was 2 instances of this, where Norfolk Southern had actually improperly loaded the train and things were pulling at both ends, and it just popped that train right off the Horseshoe Curve. And there's video of it. So you can see from the live feed that actually occurred. so Norfolk Southern figured this problem out in the Horseshoe Curve a long time ago by putting locomotives at the other end of the train. So they could work together to keep those loads properly distributed so that gravity wasn't pulling on the other end and things weren't pulling the train apart. So Norfolk Southern has done this for a long time with actually humans sitting in the locomotives at the back end of the train and pushing. In technological development, you can actually put a locomotive that actually has RF communications that's in the 400 megahertz range. These two, the locomotive in the back and the locomotive up front, will actually talk to each other. And you actually are now controlling the distributed power, which in the image up above here, you see a lead locomotive, what's called an MU, and then a distributed power, a DP locomotive later in the train. And all these locomotives talk to each other and control each other. The lead controls, the MU and the DP.
I'll make a comment.
Sure, go ahead, Mike.
K3MT. I used to work years ago for FCC. We had a problem in a coal train line over in West Virginia. It was a really tight turn. They had multiple units, and when they went around one particular bend, they lost that 450 meg communication. The other power units would then sort of go back to throttle down and brake, I guess. It was tearing the train apart. And the fix was to put a 450 megahertz relay over across the mountain so that they could fill in that valley and run those trains properly. That was many years ago.
That is actually what happens a lot in the mountainous territory. They actually add repeaters in to enable better connection link, because like Colorado, if you're going up towards the Moffat Tunnel, there is a lot of tunnels along the way, and that's a high grade. So if anything cuts out, you've got problems. So UP's done a pretty good job of covering it. Norfolk Southern's solution is actually to avoid using technology, and they actually have a crew assigned to help their locomotives, and so they don't even use the distributed power technology that much out in the Horseshoe Curve. Of note as well about distributed power, we definitely can dig into this topic quite a bit. Of note right now is that there's a new move towards precision scheduled railroading within the industry. And with precision scheduled railroading, there has been an increase in the length of trains, not necessarily a reduction, although COVID has done its fair amount to reduce some business for the railroads, but the railroads have actually started building longer trains to by taking apart where one day you might have 3 trains, now you have 2 trains, and you split the loads between these other 2 trains. There's it's called very long trains. CSX, for one, has actually started utilizing distributed power. As just from my own personal kind of observation, they've actually started using distributed power more frequently than I have ever seen before. And a lot of that is because they're trying to increase their train length and maintain proper loading. So,
what's the maximum length of a train? Is there such a thing?
Well, I don't know of the actual physical maximum length. There is actually, as I recall, there's no regulatory maximum length. However, and this takes a lot of modeling and experimentation. There seems to be, and keep in mind this is solely my opinion, seems to be maybe around 250 cars. You have to start thinking about distributed power and not having all your power up front. So that's kind of what I've seen as kind of a limit, and that's when they start thinking about adding more power. Yeah, go ahead, Dennis.
Yeah, just as a side note also, I've ridden the Amtrak auto train quite a bit over the last couple of years.
Yeah.
And my last trip, I guess it was back in August, I actually noticed CRX used in the distributed power, and I couldn't figure out what it was at first, and all of a sudden it dawned on me, they got an engine in the middle of the train. And I don't think it was that particularly long a train, but of course the Amtrak auto train is supposedly the longest passenger train in the world if you count the car carriers. But It just struck me a little strange. It didn't seem that long, but yeah, I saw them using it on the lines between Lorton and Florida on that weekday.
That K4-1A?
It's become certainly more popular in general for CSX, and I think some of it is they are trying to, even in areas where it's flat, they might be trying to mitigate any loading issues that could occur. There's a lot of work that's been done on modern locomotives to increase tractive effort and decrease the number of locomotives, but also optimize all of that so that, like, there was a time when horsepower was kind of constantly increasing, and there was kind of a constant desire to increase horsepower. And so the result of that was 6,000 horsepower locomotives that were like the top of the line. Well, all the 6,000 horsepower locomotives that GE built, pretty much all of them that went out into the field ended up getting derated down to 4,400 horsepower. Reason being is horsepower is great for speed, but when you're talking about heavy loads, you need tractive effort. So there was more study put into tractive effort, increasing tractive effort, and CSX has actually done a very, very good job of working closely with the manufacturers, locomotive manufacturers, and I know specifically GE, to actually increase the tractive effort of a locomotive purely by increasing the weight of the locomotive. And so a lot of CSX locomotives, you'll see, it might say the model number might be like ES44AH. That AH is high adhesion, which means that there's actually ballasted in the locomotive somewhere. So, and actually another thing to note about tractive effort as well, the locomotive you see in the lower left corner, that's an AC locomotive, AC traction. And I was very tempted to put a bit about the control system and how the diesel locomotive transfers power into the traction motors. However, I figured that would be quite the subject to dive into. AC traction has proven, and you know, as you distribute those axles out, you actually have less tendency to tear up the rails. Except in AC traction, you don't have to worry about that anymore. DC traction, if you had a locomotive and you notched it right up, your tractive effort, you know, you'd start tearing up the rails. With AC power, that's actually not an issue anymore. So that's why they've actually, one of the many reasons they moved over to AC traction in general. So we covered distributed power, covered multiple unit. I'll say one last thing about this slide and then we'll move on. Multiple unit is actually the wired connection between locomotives. There is a giant connector that's probably around the size, bigger than your fist, that has a bunch of little pins in it that gets connected in between the locomotives, and you have control. That can also be used for passenger cars and other things. There's a whole bunch of detail in that I won't go into tonight. All right, braking systems. I'm gonna try to go through this very, very quickly. It's one of the more complex systems on a train. There are a series of different brakes that exist in the train. Most common brakes are going to be the brakes on the locomotive, which are an independent brake, which is a pneumatic friction braking system. There is also a dynamic brake on the locomotive. We talked a little bit about electrically powered traction. Because the traction motors are electrical devices, dynamic braking allows, what it does is, best way to explain it is the hybrid car with regenerative braking, except in the locomotive's case, instead of taking that motion and transferring it into a battery, instead dynamic brakes are essentially taking that motion and transferring it instead into a giant resistor, and essentially just exhaling all of the heat that comes off that resistor. And there's a little bit of recharging things and using it, but it's essentially just spewed out into the atmosphere on the side of the locomotive. And actually, if you look at these little locomotives up top here, and you see this three little vents here, on a GE locomotive, those three little vents are going to be where the exhaust comes out from the dynamic brake. Okay, so dynamic brakes, I covered that a little bit. The train brake that goes throughout the entire train. So historically, there was these hand brakes that what would happen is you'd have to run down the train and turn these big dials, and they're a mechanical brake. They're now used to actually stop a train from moving, keeping a train stopped. So when you bring a train to a stop and you tie down, as we say, you go back and you actually activate a series of hand brakes because those are pretty much, they're going to stick and they're going to keep things from moving. The air brake system goes, it's another braking system that goes throughout the entire train via a pipe. And that pipe gets filled up with air from a compressor from the locomotives. And then air off of that goes into a reservoir, which, as you can see here, there's the control valve and reservoirs, and then there's a brake cylinder. And what happens is that air goes into those reservoirs, and when the pressure from the brake pipe drops, the reservoir then pushes the brake cylinder in and actually actuates the brakes. And now you actually have a stopping motion, so that if you have a leak within that airline that goes throughout the whole train, it will fail safe by applying the brakes. What's pretty important about that in the whole scheme of communications is that there's a lot that you need to know about your brakes when you're operating a train. The locomotive is, of course, going to be providing a lot of the air, but something I'm going to talk about in just a sec is the end of train device, which actually helps with distributing the any type of application of brakes. So when you want to release the brakes, you're going to have a release at the front, but you can actually, because of an end of train device, have a release in the end.
I've worked on a project where the end of train device used a turbo generator to generate electricity and transmit stuff back to the head of the train to give all types of
Telemetry
information about speed, location, essentially replaced the caboose.
Yes, Mike, you're absolutely right. They replaced the caboose right about in the 1980s. The technology became good enough. They could communicate back. The whole idea, and there's a bit of technical information here I have. However, what I will say, down below in this monitoring software section, this guy, I think his name is Eric Reuter, he is also a ham, and he's a bit of a hacker. He gave a really good presentation at DEF CON that's actually available online, and about his experimentation with actually digging in and trying to see what he could do. And there's a few pieces of software. Soft EOT listed here is another one that can actually read from the end of train device, but he actually created an open source code that can read from this thing. You attach up to it your, one of your RTL SDRs, or even an HT, feed the audio feed into this code, and you can read out all kinds of brake information. And what's contained in there is going to be the ID for the device, and what the brake pressure is at the end of the train. That helps kind of mitigate any leaks or anything. You can know that there's a problem a lot easier, because you say the brake pressure at the end and the beginning are not the same. When it comes to railroad communications, I'll say this device is one of the most fascinating in a lot of ways. There's a lot to get from it. If you're ham, you can kind of look into this. It's kind of a neat thing. I wish I could give, each one of these topics I'm trying to touch upon, I'm trying to just touch upon it because there's just a little too much to cover in all this. So, but I recommend looking up Eric Reuter's presentation about this. But to get you started, if you really want to just start hearing things, program these frequencies into your HT or your radio on your car and just start listening. You'll start to hear little blips. And then you might get the bug and start digging in more. But essentially, yep, it's the old caboose. That's pretty much the main slides of the content for communications. However, I know there's a lot that I didn't touch upon, but a few other interesting facts. I know some things that have been mentioned might be here. just a few tidbits of information about the industry in general. Railroads are classified based on their revenue, and they're classified into three classes. Class 1s are the largest railroads. We're all probably familiar with CSX being in this area, Norfolk Southern possibly. Union Pacific tends to have a reputation, as well as BNSF. Of course, there's 3 other Class 1s, which is Canadian National, Canadian Pacific, and Kansas City Southern, which some refer to as the baby Class 1, but that's doesn't mean they're a small railroad by any stretch. And then Amtrak is occasionally actually grouped together with the Class 1s because of the size of its operation, but it is a passenger railroad, and most passenger railroads, depending on the passenger railroad, freight railroads are really the ones that get classified by revenue. There's also these things that are holding companies and other forms that, Genesee, Wyoming is a type of holding company. You can see actually on the right side here, here's a picture of a locomotive, 2 locomotives that are owned by a Genesee, Wyoming subsidiary. They are a series of very little short lines all across the country, but they are not, they actually can match operationally the size of a Class 1 in certain ways, but they're not considered a Class 1 because they are a smattering of short railroads all over the place. A few other items to mention. There's a lot of stuff. If you dig into railroading a little bit more, you'll learn a lot about mergers and acquisitions and what's going on. I mean, CSX is really the Chessie Railroad and the Seaboard Railroad that combined. So that was kind of a merger. And then, of course, both the Chessie and the Seaboard are now are called fallen flags. And then I also know PTC. There's going to be a lot more to look into about PTC in the future when it comes to railroading. But currently it's been declared by the FRA that PTC has been 100% implemented. So I was going to include a link to the website. I forgot to, but you can go check out the FRA's website, and there is actually a PTC link there to also look at. I see a few people actually posted links to YouTube as I've been talking. There is a channel on YouTube called Virtual Railfan. Ashburn, Virginia, or is Ashland, Virginia, I believe. No, Ashland, sorry, it's not Ashburn, Ashland, Virginia. There is 2 different camera feeds on the train station in Ashland, Virginia. You can actually watch trains go by all day. There are times, I won't admit it, but I've seen a few trains go by in Ashland on a camera. It's kind of fun just to, it's free. Okay, I didn't realize I had 3 now. It's kind of a neat thing if you're really, itching to watch a train and you're sitting at home. It's kind of nice. And a few other things I mentioned. I didn't even breach the topic of track circuits. And there's a lot to cover in that territory. I'll say a few words like block signaling and signals and aspects. If you happen to be lucky and find something like this kicking around, or in certain other cases, one of these somewhere. Oop, there we go. They give you a good idea, and I wish I could have presented a bit more about it, but you can see, all the signals, aspects, and indications. What they mean, of course, they are using railroad language. So there are certain things that if you're not familiar with the language, you may end up having to dig in a little bit to figure out what it means. One thing I can think of is like restricting speed, which is it's a very subjective speed, which is you cannot travel, you must be able to stop within half the range of vision. And so it's a speed that you are able to stop within half the range of vision. So if you imagine driving your car and your speed is limited by how far you can see, you have to make that subjective judgment as you're operating your car that I can stop within 10 feet at such and such speed. That's restricting speed. It's probably one of the most significant aspects of operations that actually relates to PTC, because it's an area that you may see a few things going on with PTC where restricting speed has been causing or could cause an accident, and PTC could not prevent it. not to mention PTC, not to dig into it, but that's a bit about that stuff. And like I said, there's a whole lot relating to railroad communications that goes into block signalings and all that stuff and signals and train controls. But unfortunately, I'm not going to cover that tonight. And then buff and slack are forces that occur within the coupler and the rail car. So if you think about every rail car has a little bit of slack in it. When you start up the locomotive and start moving, every car starts moving independently, one at a time. That is because there's a certain amount of slack put into the couplers. Buff, on the other hand, is the inverse of slack. So those are essentially when you have, compression or extension. Those are the buff and slack forces going on. If you're looking for something fun and really frightening to watch on YouTube, look into rail buckles or sun kinks, SUNKINKS. If you look into rail kinks and rail buckle, it's a phenomenon that the rail will be sitting nice and straight and almost instantaneously curve or bend or change its shape. It's kind of a fascinating phenomenon to see. I recommend looking it up on YouTube. But I will say it might scare you. However, rail buckles occur because of several different things going on, one of which being rather significant temperature swings and also incorrect adjustments for what's called rail neutral temperature. Once again, I'm not going to go into too much more detail at the moment. I'm already way over time. So if anybody wants to ask and talk about that, we can talk about it in a few minutes. But I'll just kind of finish off the last few items. There's some high-speed rail to look at, the Acela and the Texas Central, two things to really look at within the US, although the Japanese, the Chinese are doing high-speed rail in a way that we still aren't even doing yet. And then the last thing on this slide of significance, well, there's two last things, foamers, which if you're standing by the tracks and you're holding a camera, the operator, the locomotive may just call you a foamer. It's just the industry speak for rail fans, and it's a thing that's just, you just deal with it. You just have to accept it. And the last thing I'll mention on this slide as well is the two major locomotive manufacturers at the moment are GE and EMD. And amongst foamers, Alco is still the best. But I'm a little bit loyal to GE myself in my personal life because I've worked on their locomotives. So, all right. So I put this one slide in here. What about steam? Because I try to cover a lot of ground. Steam's fun. Everybody loves steam, but it's definitely not got the same technological advancements that modern locomotives and rail has. So there's not much other than to show a pretty picture of steam at this point. I've heard though, I haven't been back to the New Hope for quite some time, but I have heard that station and that locomotive are not in as great shape as they were the day I was there. So it's kind of a bittersweet memory, but I love steam. I do love a good steam locomotive. When 611 came around, I was out there. I got onto it. I had a good time. So you may have guessed, pretty much all the pictures in this presentation are pictures from my own travels for both work and fun. I'll just for the heck of it, I'll go through and explain a little bit about each of these pictures. The one in the upper left corner there is at the Cary Furnaces up in Pittsburgh, and it's an old switcher. Before I really knew a lot about railroading, I took that picture, and it just was such a decayed locomotive. The middle picture on the top is the Shinkansen. I think it's the N700. I don't think it's the first N700. I think it's a second. And that's actually a train I took from Tokyo to Kyoto back in 2016. On the right, I believe that is a Kazakh locomotive, or now owned by the Kazakh government. It's a former Soviet locomotive, and if you are at all good at Cyrillic, you'll notice that the first two letters on that number board up front is actually VL, and it's a VL80 locomotive. That is Vladimir Lenin, and then the model of the series 80. So it's a Vladimir Lenin 80. A lot of the old Soviet locomotives are VL with some number. The VL80, when I was over in Kazakhstan, was probably the most common locomotive that I saw. In the lower left corner, that is a ET44AC. ET44AC. So it's one of the newest, actually, yeah, okay, it is. One of the newest CSX locomotives or GE locomotives that CSX had purchased. And the cars at the end are the FRA track inspection cars. That steam locomotive is going to be the same New Hope locomotive you saw earlier. And then finally, the Bangor and Aristic locomotive is a heritage locomotive up in Brownsville, Maine, which all this talk about gauge, the reason I mentioned that gauge is topic here, the Japanese, the Shinkansen uses 56.5 inches, so American standard gauge for their Shinkansens. However, everything else is narrow gauge. I cannot remember the exact gauge. The Kazakhs use the Russian gauge, which is 5 foot. In Maine, there are a number of tourist lines that you can go and see, and they actually use 2 foot gauge. Way back when in Maine, a lot of the forest operations were done on 2 foot rails or 2 foot gauge.